Hi, my name is Ari Berger and I'm the Chief Technology Officer of Hillcrest Energy Technologies. In Hillcrest, we designed a transformative technology for inverters. We call it ZVS technology. I'm going to guide you through it. Okay, so let's talk now about losses. Losses in an inverter is one of the most critical parts in the design. Not only that, it actually limits us and gives us a limit of how small we can do things. Let me explain to you. This part is something that sits in our inverter. It's a power module, and we're going to do another video about that, so stay tuned. What you can see here at the bottom part of this power module is a copper plate that needs to dissipate heat. Now, it's quite big, okay? The reason is that heat transfer is one of the biggest challenges in designing those inverters. The bigger the bigger the surface of this thing is, the more we can dispose of more heat. But on the other hand, we said that we want to make it small. Okay, so we have a trade-off here, and basically the amount of heat that we need to dissipate will determine the size of, more or less the size of the unit. So here in Hillcrest, we took this challenge, and to provide a solution to this challenge. And this is what we're doing here in Hillcrest, which is the ZVS. And let me explain to you. So there are two types of losses in these conversion devices. One is the conduction loss, which is simply because a material has some resistance. That's just basic electricity. The other type of losses is what we call switching losses. So inside this module, and you see it has some thickness and some tabs here to connect bolts and stuff. Inside of these things, there are actually silicon dies embedded inside and sitting in kind of a gel kind of thing, and they're electrically connected inside. So you can think of this power module as a switch box. That's it. And we'll talk about power modules in another occasion. So this switch box, whenever it switches, and to control the electric motor, it has to switch. Whenever it switches, there is a switching loss during the transition. We know that nothing in nature happens in zero time. Everything takes time. So even to open and close an electrical switch takes some time. And just to give you a sense of what we're talking about, could be 100 nanoseconds. That's very short for us, but that could be a long time for the electricity. So basically with the conduction losses, which is based on the physical properties of the material, has some resistance, there's not much we can do about that other than researching new materials. Wide band gap devices are being mentioned here and there. We're going to talk about that as well. But there's not much we can do about the conduction losses. About the switching losses, that's the challenge that we undertook and were successful in eliminating those. And we're going to talk about that. Okay, so at Hillcrest, we were able to develop the technology that eliminates switching losses. You're probably asking yourself, so what? Okay, so let's talk about that for a few minutes. So, as I showed before, this whole thing needs to being able to dispose of a heat. If you're eliminating part of the losses, you don't need such a big surface. When this thing becomes smaller, there's a huge cost savings here. Because remember, here inside, there are silicon dies which form a big part of the inverter. Now, by the way, in an inverter, we have 3 of those. So we just reduced 3 of those. We've reduced the size of the inverter and maybe lowered the requirements on the cooling system overall. But that's not just it. By reducing the losses, we are making the efficiency better, right? Because there is more usable electricity to drive the car itself. That by itself has an impact, a positive impact on the batteries. We might be able to have a longer range because we have higher efficiency. So every switching device is generating electromagnetic interference. There's a lot of effort going into that with filters and shielding and the casing and the connectors, because we have to withstand some certain standards of what is allowed to come out of these devices, not only from the device, also from the cabling, from the battery side. So it's really an overall system issue. We showed that using our technology, the EMI is being significantly reduced, which means that now we can save on all of these accessories that we need around the inverter and around the batteries to reduce those interferences. We can reduce the shielding on cables, we can reduce filter sizes, which then eventually goes to reducing cost and size. So that's a big benefit.